Both of these are called supervised learning, and you can see supervised learning has classification and regression. But there are certain cases where we do not have any labels, and mostly what we want to do is we want to group data into clusters, and that is called unsupervised learning. So we will also look at unsupervised learning towards the very end of this course. But our primary focus will be on supervised learning, which is classification and regression. Okay. So just to come back to the problem that we are looking at, we will train a logistic regression model using the rain in Australia dataset to predict whether or not it will rain at a location tomorrow using today's data. And this is a binary classification problem because it's a yes/no kind of classification. So let's start by downloading the data. The dataset is on Kaggle, and there are several ways to download the dataset from Kaggle. For example, you can download the data here by clicking download and then upload it to Colab. Now Colab is running on Google servers. So if you check the files tab here, this is not files from your computer. So if you want to take files from your computer, put it on Colab, then you need to use the upload button to do it. So you could download the file here, the zip file, and then you could upload it to Google Colab. And then you'll have to figure out a way to unzip it. It's a bit cumbersome. Another thing you could do is Kaggle has an API, and you can check it out here. So you can use this Kaggle API. This is a command line tool for downloading datasets from Kaggle. So it looks something like this. You say Kaggle datasets download, and you have to run this on the terminal, and you have to put a API key somewhere. So that's a bit cumbersome as well. The approach that we recommend is using the Open Datasets library. So this is an open source library that we have created to make it really easy to download Kaggle datasets anywhere. So you install the Open Datasets library using pip install Open Datasets. Then you import Open Datasets as OD, and then we can check the version of the library, which is 0.1.20. So always make sure you have the latest version, which you can ensure by running -- upgrade. So we've imported Open Datasets as OD, and then we take the dataset URL, which is this URL, the Kaggle page URL, and we run od.download the dataset URL. So let's run that. Now, when you run od.download dataset URL, you will be asked to provide your Kaggle username and a Kaggle API key. Now, where do you find that? The way to do that is click on this, go back to Kaggle. So go to kaggle.com and make sure that you sign in on kaggle.com, and then click on your username, then click on account. And here you should see an option, create new API token. So just click create new API token, and that is going to download this file called kaggle.json to your computer. Now this file kaggle.json contains the information that you need. So if you open up kaggle.json, as you have opened it up here, as we've opened it up here, you can take the username. So let me take the username. I am going to put it here. And then you will need to provide your Kaggle key. So I'm going to take my Kaggle key, put it in here as well, and hit enter. And now I am authenticated and this dataset has been downloaded. Okay, you can verify that this dataset is downloaded by opening up the files tab and checking here that you have the name of the dataset here. Another way you can do this, instead of having to manually enter your Kaggle key, is to click this upload button and just upload the kaggle.json file here. And once you do that, you will see that your Kaggle credentials are picked up automatically. Okay. And Open Datasets is smart, so it also checks whether you have downloaded the dataset already. So if it has found that you have downloaded the dataset already, it is going to skip the download. So you can specify force equals true if you want to force it to download, or if you want to force it to re-download the dataset, as it has done in this case. Okay, but otherwise it will just detect and it will skip. All right, so now we have this folder, weather dataset rattle package, downloaded from Kaggle using the Open Datasets library. All we need to do is import Open Datasets as OD and run od.download, provide our Kaggle credentials. So let's check this folder, weather dataset rattle package. This is what it's called. So we check it using os.listdir, and then it seems like there's a single file, weather aus.csv. So let's create the full path to this file. So now we have in train CSV the variable. We have the full path to the file, weather dataset rattle package / weather aus.csv. We can now load the data from weather aus.csv using pandas. Now pandas, as you already know, is a library for working with CSV files. So I'm just going to clear my notebook outputs at the moment, just so that we can get all the outputs from scratch. So I just did edit, clear all outputs to remove the previous outputs from my previous execution. Anyway, so now we have PD, pandas imported as PD, and we give it the path to the file that we have just downloaded, and that creates this data frame. So here is now our data set available to us as a data frame. We have information like the date, we have location, we have minimum temperature, maximum temperature, rainfall, evaporation, sunshine, wind direction, etc., etc. So there are a total of 20, I believe there are a total of 23 columns starting from the date. So if you ignore the date for a moment, because we're not going to use date for prediction, and then the final column is the target, the final column is what we want to predict, which is the rain tomorrow column. So we have 23 minus 2, 21 pieces of information or 21 columns of data that we are going to use to make the prediction for whether it will rain tomorrow. So we're looking at 21 weather features for today, and hopefully that should give us enough information to predict whether it will rain tomorrow. Okay. And the dataset contains over 145,000 rows. So the dataset contains a date. It contains some numeric columns. You can see here, these are numeric columns. It also seems to contain some categorical columns. You can see that the wind direction is definitely a categorical column. You can see these are strings, but you can see that there are a limited number of values that these take. So it's a good mix, and our objective is to create a model to predict the value in the column rain tomorrow using all the other columns, maybe except the date. So let's check the data types and see if there are any missing values in these columns. So in total, we have 145,460 rows of data. The date is not, so there are no null values for date. There are no null values for location. That's great, because all of this information was collected on a particular date at a particular location. But you will start to see that there seem to be quite a few null values in the other columns. And that's perfectly fine. Maybe that data was not available. Maybe that data was not measured. Maybe it was not entered. A lot of things could have happened. But one issue here is that the rain today and rain tomorrow columns also seem to have quite a few null values. In fact, you have 145,000 total entries, and here you have 142,000 values for rain today and rain tomorrow. So about 3,000 rows don't seem to have information of whether it rained tomorrow. Now that's a problem, because we want to train a model to predict whether it will rain tomorrow. So we can only use data which contains information on whether it rained tomorrow or not. I mean, if your data itself contains null values in the target column, that's not very useful for the model to learn anything, because you're not giving the model any information. So that's one issue. So we should probably remove the rows where the target column is empty. Now I want to go one step further and say that, and this is just a hypothesis now, that whether it rains today should have a very strong bearing on whether it rains tomorrow, right? So if we have missing data on whether it rains today, I think that a lot of important information is missing here in that data, even though we have a bunch of other information. So what we're going to do is we are going to drop all the rows where either rain today or rain tomorrow are null. Okay, where either the rain today value or the rain tomorrow value are empty. And the second one, it makes sense because it's a target column and we should only have rows where we actually have a value to predict for the target column. But the first one, rain today, I'm just taking a guess here saying that, hey, if I don't know whether it rained today, it's going to be very hard to predict if it's rained tomorrow. Okay, so I'm going to just run raw_df.drop NA, rain today and rain tomorrow in place. So from raw_df, we are going to drop this information. And now if you check raw_df dot